Question 5a. The figure below shows a roller coaster. The roller coaster car is raised at a vertical distance of 35 metres to point A by a motor in 45 seconds. The mass of the roller coaster is 600 kilograms. The motor has a power rating of 8,000 watts. Calculate the percentage efficiency of the motor. I use equations, really important, from the equation sheet, and also it gives us gravitational field strength is that, and it's worth 5 marks. So straight away I can see this is a complicated equation, a complicated calculation question. Okay, so I know how much the power rating. I know that power equals energy divided by time. So I'm looking here at different things. I've got time. I've got a power, obviously. I need to know for efficiency. So the first thing I'm going to do actually is I'm going to go back to my every. I'm going to write down the equations I know I need. So the first equation, and I'm going to think about my space I've got here, because this is going to be, I'm going to have to do quite a lot of different sums here. So first of all, I'm going to look at percentage efficiency. Well, I know that percentage efficiency equals, and I'm going to look at power, so useful divided by input times 100. Okay, that's my efficiency, and I'm going to do that calculation in this column here. So I'm going to give myself a column to do that. So I need to find the useful power and the input power. Okay, well I've got the input power there, that's my input power. Sorry, so the second thing I'm going to do is my values and convert if I need to. So I'm going to give myself a bit, I'm going to rule down here again, and put my values on the right hand side. So I've got my input power first. I'm moving this around a bit. My input power equals 8,000 watts. And I need to find my output power. Well, I know that output power is energy divided by time. So how am I going to work that out? Because it doesn't tell me the output power. But I can work it out because I know that I need output power, useful power equals energy divided by time. Well, I know the time is equal to 45 seconds. So how am I going to work out the energy? Well, the energy in this case, I'm lifting something up. So it's going to be equal to GPE divided by time, and I know that GPE is equal to mass times gravity times height divided by t, and I know those things. Okay, I know what GPE is, so I know that my mass is equal to 600 kilograms, 600 kg. I know that G is equal to 9.8 newtons per kilogram. I know T, I've already got time, H is equal to 35 metres. I'm just going to check, have I used all the values? I've got 35 metres, yep, got that. 45 seconds, yep, got that. 600 kilograms, yep, and yep. Okay, and that. So I'm using all my numbers, so I can see now where they're all going to go. Now I'm just going to put them back into the equation. So my useful power was 600 times 9.8 times 35 all over, so divided by 45, which gives me a total of my useful power, so of 600 times 9.8 times 35 equals that, divided by 45 equals, that gives me a total of 4,573.8 3. Avoid using the dot notation. Okay, always avoid using that. So we don't do the dot notation. Okay, so that's my useful power in watts. I'm then going to use that back over here because I know that I wanted useful, which was 4573.3 divided by input, which was 8,000 times 100 equals 57.2%. Okay, so the way I've laid that out, okay, I know I've got some scribbles there, but hopefully it becomes it's very easy for the examiner to find out exactly what I've got to do. And the way I did it was I broke down the equations in order, so I know I needed to find efficiency, useful over input. I had input, but I needed to find useful. So then I thought, right, well, how do I find useful? Well, I find useful by using power equals energy divided by time. So there's that. This was in my equation sheet. They also had in my equation sheet GPE equals mgh. That was also in my equation sheet. So as soon as I recognise that goes in there, that is that energy. I substituted it into here. I didn't try and work anything out too early. I just wrote down the values I had and then put the values into the equation. The reason I do that is to make sure that I get the substitution marks in case I made a mistake over here. But in terms of clarity, this is a really clear way. I might possibly have had another equation here saying energy, GPE equals, and I might start at a different line. That's fine. Okay, keep it here. That makes it easy to read, I think, is the column notation. Okay, hope that's useful.